Hi. So far in this series of videos, we've been talking about how different components work together inside of Rasa. And this is a great starting point, but it doesn't discuss the process of actually creating a virtual assistant. So let's talk about what this process might actually look like. And it's important to be explicit about this because there's a risk that we might not do it right. You see, when you get started with a virtual assistant, you might start by creating a dataset on your own first. You might come up with a couple of intents and a couple of entities, and you can train machine learning pipelines that try to optimize for this dataset. You might even go as far as to try different pipeline configurations to see which one gives you the best classification scores. Now, optimizing is great, but it only works if you're 100% sure that the dataset represents what your end users are actually interested in. It's a common challenge in machine learning in general, but it's especially important for virtual assistants to get this right. You might be missing some intents, and the only way to figure this out is to actually listen to end users. The challenge with building a great AI assistant is that it's impossible to anticipate everything that your end users are going to ask to your assistant. The opportunity, on the other hand, is that in every conversation, users are telling you exactly what they want. This is why we advocate a process known as conversation-driven development, or CDD in short. The goal of the process is to learn from end users of the virtual assistant in order to make improvements. Your users are going to be the main source of truth, so as a process, we recommend very consciously taking the following actions. First, you want to share your assistant with users as soon as possible. Once your assistant is shared, you want to review conversations on a regular basis. During this reviewing, you'll want to annotate messages and use them as new NLU training data. And this is something that you can also use to test that your assistant is always behaving as you expect. Eventually, you'll be able to track when your assistant fails, and you'll also be able to measure its performance over time, which in turn allows you to fix how your assistant handles unsuccessful conversations. Now, these steps, they describe a process, but this process is not a linear one. You'll circle back to the same actions as you keep developing. Every time that you share a new version of the assistant, you have the opportunity to collect conversations between your assistant and the end users. You can review the conversations, label new data, and find ways to improve the assistant. You're even able to add test cases that can be checked automatically at every new deployment, which means that each new iteration won't just improve the assistant, but it can also improve the continuous integration, continuous deployment pipeline by creating a more complete test coverage. To make all of this easy, we've created this tool called Rasa X. It is our tool built on top of Rasa that makes conversation-driven development easy. And what I would like to do now is show you a very quick demo of a local installation with Rasa X so you can just see some of the features that it offers. What I've got here is a Rasa project inside of Visual Studio Code. It is the project that you get when you run Rasa init, so it's the basic moodbot example. And this project also has a model that's already been trained. What I would now like to do is demonstrate Rasa X that's running on top of this project. But in order to do that, I first need to install it. So from the virtual environment that I'm currently in, I am pip installing Rasa X. And the thing to pay attention to is that I'm installing it with this extra index URL. Effectively, that means that we're using the Rasa PyPI service to install this package. So let's quickly install this first. And with that installed, I should now be able to run Rasa X directly like this from the command line, which will start up a service for me. A browser window should now have opened up, which is pointing to the URL that you see here. Note that it generated a username here with a password, and this password is going to be different every time that we run this Rasa X command. But on our local host on port 5002 on this URL, we can now explore Rasa X. And here's what the Rasa X interface looks like. To give a quick demo and overview, let's move our mouse cursor to the left-hand side over here, and here we should see a couple of options. The first thing I'll just quickly explore is this NLU data tab that you can find under training. Here you can see lots of training examples that are in our project. There are these different sentences, and we can indeed see that they belong to different intents. We could also check regexes and synonyms if we were interested. From here, we can also have a look at some of our stories. But one of the more interesting things that you can do from here is you can go to this Talk to Your Bot section over here to actually talk to your assistant in the Rasa X interface. So I'll quickly talk to it for a bit. I can say hi. It asks me, hey, how are you? And in the demo assistant, if I were to say, I am sad, it will try to cheer me up with a picture of a tiger. Now, a few things that are nice. For starters, we're able to actually render images here as well as buttons. We have a proper user interface at our disposal here, as opposed to a terminal. But something else that's neat is that under each utterance here, we see an intent prediction. And for every action that we get from the assistant, we also see the action prediction with a confidence score. We also see the story over here that's being developed. And what we can easily do from here is we can take this story that's listed and use this as a test example. All of these features are great, but one thing that's especially cool is that when you have a conversation like this one, you will notice that it pops up in the Conversations tab. Any conversation that any user will have with our assistant via Rasa X can be found over here, and every single example can be inspected here. We also have our NLU inbox, and what this allows us to do is it allows us to label sentences that haven't been labeled yet. And in this case, I can say that the sentence I am sad that I just typed does belong to the mood unhappy intent, so I can say that that's correct. From here, what I could theoretically do is I could go and hit this train button that you see over here. Theoretically, we have just collected new training data, so when I hit this train button over here, a new Rasa pipeline will be trained, and we should see a new model appear in the Models tab that we see listed here. This has been a very quick overview of some of the features in Rasa X, but by far one of the most interesting features is the button over here. From here, I'm able to create an interface that I can give to users that don't have the Rasa X credentials. I can say this is going to be a demo, and from here I can generate a link. When I copy this link, and when I put it in my browser, it looks like this. And this is the interface that you might give to, let's say, a colleague. And then your colleague could write something like, hi there, my name is Vincent. Now, all the data that's being generated here is viewable inside of Rasa X as well. If I now go back to my Conversations tab, we can see that indeed a new conversation has popped up in here. And when we go to our NLU inbox, we can also see that hey there, my name is Vincent has also appeared. So that's great. We can see that we have data that's coming in. However, there is one thing that we probably want to change. The interface that we have here is nice, but the only way for people to get here now is if they have access to localhost port 5002. Even if you're working on your laptop locally, when you want to share something with a colleague, you typically don't want to do that over localhost. So I'm quickly going to demonstrate a trick that you can do with the ngrok command line app. The first thing to observe is that we are hosting our Rasa X instance on port 5002. And what I can now do with ngrok from the command line is I can say, well, let's, over HTTP, let's open that up. Let's allow the internet to communicate to the port that I've got locally. When I start this command, ngrok will run a proxy on my behalf. It is going to say, well, this public-facing URL, that's going to map to your local host. And that means that I can use this URL to construct a path that my colleagues can visit. So what I'm going to do now is I'm going to take this ngrok URL, which is pointing to localhost 5002, And I'm going to replace the localhost part with the ngrok part. And it's this URL that I can share with my colleagues. And there we go. We now have the ngrok link that we're using to generate this widget, which allows me to collect data. I could, for example, type yo to the assistant, just to see what would happen. And the assistant seems to be making a mistake. Yo can be a way to say hello in a conversation, but the assistant isn't picking this up correctly. Let's see what this looks like inside of Rasa X. If I were now to go to my NLU inbox inside of Rasa X, you'll see that yo is indeed something I can label now, and we can confirm that it's not picking up the right intent. So I can say here, well, let's change that. It should be a greeting, and let's add that as a label. If I were now to go to my NLU training data over here, we should see that yo has indeed now been added to my training data, which in turn means that I could now go ahead and retrain the model. And what I hope you're seeing here is that this is indeed an iterative process. I'm able to share my assistant early on with some users that are able to give me feedback, and it's this feedback that will make this assistant much better, which is why we emphasize sharing your assistant early. And I also hope you recognize that Rasa X is indeed a very convenient tool to handle all of this feedback. I've now shown you how you can get started by running Rasa X locally on your laptop. It's a great starting point when you want to share the assistant with your colleagues, but very quickly you'll want to host the assistant on a server instead of on your laptop. When you use Rasa X on a server, you'll get access to even more features. But before diving into those, it helps to understand how Rasa X interacts with Rasa. Let's say that you're running Rasa open source. Then the simplified architecture might look something like this. I've omitted the tracker store in this diagram as well as the action server, but we do show that Rasa open source has an agent that is able to communicate with the end users via the input-output channels. Rasa X should be seen as a separate service that is able to communicate with Rasa open source. Now note that Rasa X needs to be able to trigger a retrain event. So it needs to be able to communicate directly with the agent inside of Rasa open source. That's why Rasa X doesn't communicate via the input-output channels. Likewise, the agent also needs to be able to send events to Rasa X. Whenever a user types a new utterance that needs to be labeled, Rasa X needs to be made aware of that. So conversation event data flows from Rasa open source to Rasa X via an event broker. And Rasa X in turn makes API calls to Rasa open source to train, run models, and trigger conversation events. Now in this diagram, we do need a unified way to route users to the right service. We want algorithm builders to interface with Rasa X, but we want all output channels to directly connect to Rasa open source. That's why a server deployment of Rasa X will also include a Nginx service. Nginx runs as a separate service, and it will be the gateway to the outside world. It routes traffic to the appropriate Rasa input-output channel or to Rasa X. It can also be configured to use SSL, which allows your traffic to run securely over HTTPS. This diagram gives a proper overview, but it really deserves to be stressed that it is a simplified overview of the architecture. For example, there is a metadata service that Rasa X uses that we haven't drawn in this overview. This metadata service is useful when we're labeling. We want these labels to be around, but there is one component that can connect to Rasa X that definitely deserves a highlight. And that is your Git provider. Rasa X can connect to GitHub or GitLab to keep updates in sync. Newly labeled data can be pushed to GitHub automatically, and any new data points added to GitHub can also appear in Rasa X this way. This also means that you can leverage the CI/CD tooling from GitHub or GitLab whenever you want to redeploy your assistant. Now that we have this architecture overview, let's conclude this video by showing you a quick demo of what Rasa X might be like when it is deployed like a service and communicating with GitHub. What you're looking at here is a Rasa X installation installed on a server. In particular, what you're looking at is some training examples for my personal Slack assistant. One of the things that I would like the assistant to do is to remind me how I am supposed to make a expense claim. So I'll add an extra example just for good measure. I could say I have a bill and it needs to get paid. And this would be for reimbursement. So far so good, but I would like all of these examples to now also appear on my GitHub repository. Now, because this is a server installation of Rasa, what I'm able to do is I'm able to go here and see this Git tab. This has been pre-configured by me, but you can see that it's yellow. There are changes that are on this server that are currently not on my GitHub repository. So what I can ask Rasa X to do is to add these changes to my Git server. I could choose to add this on a new branch, but adding this to main should be just fine. And after a while, we see the color change from yellow to green, indicating that the data has now been added. This is the GitHub repository before the change. And let me now refresh the page. I can see that a commit was made 32 seconds ago. And in particular, I can also confirm here that the change was made in the data folder. And if I go here and I check the nlu.yaml file, I can indeed confirm that the I have a bill and it needs to get paid example, that has now been added. I can also do it the other way around. I can change this file, scroll down, and add another example. I have another bill. It needs to get paid. Again, I'll commit directly to the main branch. And if I now go back to Rasa X, it takes a minute before it's fully synced, but I can now confirm that the I have another bill, it needs to get paid example, that is now also in here. And this is great because that means that I have a Rasa X service running that is able to communicate to GitHub. And this is great because a service like GitHub will be able to handle a lot of my CI/CD tasks, and this link will make sure that any changes that I make to my project locally, that when I push them to GitHub, that they're also available from Rasa X that is running on a server. In this video, I have shown you how Rasa X can be used. You can use it on your laptop to share with your colleagues, but you can also share it on a server, which allows you to share your assistant early on to many end users. The main thing that's important, though, is the idea that you listen to your users. Sure, when you make virtual assistants, a lot of folks say that it's important that your assistant is able to say the right thing to the users, but I would argue literally it's more important that we actually listen. It might be that there's intents missing or that users have a certain preference that we're not aware of, and the only thing that matters when you're making an assistant is that you're making life for your end users easier. Very typically, you don't need super fancy machine learning models in your pipeline. It's definitely better to instead invest in understanding your end users. So if you're building an assistant with Rasa, definitely keep this idea of conversation-driven development in the back of your mind.